Imagine trying to understand human emotions without tone of voice or facial expressions. It would be flat and confusing. Neural networks face the same problem without activation functions. In this video, we're diving deep into what activation functions are, why they're critical, and how they transform raw data into intelligent decisions. Activation functions are mathematical formulas that decide whether a neuron should fire or not. They introduce nonlinearity, which allows neural networks to learn complex patterns. Without them, your network would just be a boring linear equation, unable to recognize images, voices, or even text. Imagine teaching a child only straight-line patterns. They could never recognize circles, curves, or complex shapes. That's what happens if you don't use activation functions. Neural networks need them to capture the richness of data, like distinguishing a cat from a dog or positive from negative sentiment. One of the oldest activation functions is the sigmoid. It squashes values between 0 and 1, making it great for probabilities. But it has a downside. It can cause something called the vanishing gradient problem, where learning slows down drastically. Next is Tanh, or hyperbolic tangent. It's like a cousin of sigmoid, but instead of ranging from 0 to 1, it ranges from -1 to 1. This means it's centered at 0, which often helps models learn faster. But, like sigmoid, it still suffers from vanishing gradients. Then came the superstar, ReLU, or rectified linear unit. It's simple. If the input is positive, keep it. If it's negative, output 0. ReLU revolutionized deep learning because it reduces vanishing gradients and is super efficient. But it has a flaw, the dying ReLU problem, where some neurons stop learning if they output 0 too often. To fix ReLU's issues, we got Leaky ReLU, parametric ReLU, and ELU. These allow a small slope for negative values instead of a flat 0, keeping neurons alive and learning. Think of it like giving a safety net to neurons that would otherwise be ignored. Finally, we have Softmax. This one is used in the output layer when you want to classify something into categories, like deciding whether an image is a cat, dog, or bird. Softmax converts raw scores into probabilities that sum up to 1, making it perfect for multi-class classification. So, how do you choose the right activation function? Sigmoid and Tanh are mostly for smaller, simpler models. ReLU and its variants dominate in deep learning today. Softmax is essential for classification tasks. The choice depends on your problem, data, and network architecture. Activation functions are the unsung heroes of deep learning. They turn simple math into powerful intelligence, enabling machines to see, speak, and understand. Remember, without activation functions, neural networks would be just linear calculators. With them, they become intelligent problem solvers.